Hi, welcome to another episode of Yummy Data Science. In the previous episode, we talked conceptually about model validation. We talked about three different methodologies, the 80-20 split, the k-fold validation, and leave one out, which is an extreme case of k-fold validation. And now what I want to show you is on our readmissions data, how this works in Python in Google Colabs. And you'll see that I'm using the sklearn library. And while I could have written this code out, I'm showing you that you can also use AI. I have, however, been gradually thinking that perhaps AI encoding is not quite as advanced. So what I will do is I'll write out a prompt and then I'll look at the code generated and then I will tweak it. And I know from experience what the code should be, but if you don't know what it should be, then perhaps going back to textbooks or articles is a great place to start instead of relying solely on Gen AI. So I started out by prompting it, redo the logistic regression by taking the 80-20 training testing split. So you can see that I'm already using the lingo and I'm saying create a confusion matrix using a probability of 0.65 as threshold. And if you recall from the previous video, and you'll see the confusion matrix again, is that the confusion matrix is going to try to put side by side what the actual values are. So readmission yes versus no, and what the predicted values are, readmission, predicted readmission. And what the model does is it creates a probability of readmission. So then you have to figure out, well, what's my threshold? So the threshold of 0.65 means that if the predicted model probability of readmission is 0.65 or above, then I'm going to classify it as a model predicted of readmission yes. Okay, so let's quickly peruse this code. From the SK model, it is model selection. It's importing train test split, and that's its way of dividing up the data between the training and the testing. And then from the metrics, it is taking the confusion matrix. So now you're extracting submodules from the sklearn library and utilizing them. So the first thing we do is we create an x, y, and so x is all the explanatory variables. Y is the predictor, what we are trying to predict, the readmit flag, and then we are splitting the data. The test size of 0.2 is telling it that it should do an 80-20 split, and the random state is ensuring that every time you run this code, the same observations are sent to the training and each time, and the same observations are sent to the testing data set. So now we go ahead and we train the model on our training data sets. Then we fit the probabilities. And remember, what the Python code is doing is it's outputting two sets of probabilities because there are two classes, positive and negative. Readmission yes, readmission no. So here we are saying we are taking the probability of class 1 as opposed to no, which would be it was not, it's the probability of readmit. And then we are putting our threshold to 0.65. And this code was generated through the AI facility that is embedded in Google Colab. So now we come up with the ypred using the threshold, and the confusion matrix is created. So you can see I've printed out the confusion matrix, and I will, it's nice to see this in the same way that I had my PowerPoint presentation. So I put another prompt, plot the confusion matrix. The plot should display only two colors, green for when actual values equal to predicted values, and red for when actual and predicted values are not equal to each other. And I played around with the statistical lingo like discordant and cordant, but concordant, but it didn't quite get it. So I made it very clear. Actual values equal to predicted values, and red for discordant values, but I spelled it out. And so it did that, and it did it in a reasonable manner. There is a problem here, which I will leave the watchers to figure out. So it did that, and I also asked it to print the overall accuracy of the model and to display the formula. So I did that in the prompt. Let me show you that. Here is my prompt. So compute accuracy, displaying the formula and value of accuracy in the title. So it did a good job of that. So accuracy is how many rows did the model get right, whether it was in predicting the positives or the negatives, and it's a ratio of the total number of rows, and it's 0.73. So it's actually pretty good. Now I'm going to do the k-fold validation. So again, I used a similar prompt with k equal to 4, create a confusion matrix, and then I simply copied it. The only thing I said was differently is that report accuracy is the average accuracy. Recall that when we do the k-fold validation, it's going to do with k equal to 4, it's going to do 4 different cuts of the data, and it's going to do validation and training 4 different times. So if I want to report the accuracy, they'll be available at each fold level. So I want to average it out. And then same thing with the confusion matrix. I want to sum it up. And so it did that. And then I made sure that I understood this code and it looked right. So here is my accuracy, 0.78. It jumped up because now remember we are doing 4 models. And so now our validation is each of those 4 models, and then it's added up. So presumably, if we were to put this model into production, we would take the entire data set and get an algorithm out of it. We won't leave anything out. This is just for validation. So the average accuracy has jumped up to 0.78. And here's the corresponding confusion matrix. And then what it turned out is that because it was adding up the confusion matrix, and I need the confusion matrix to be in integers, and for those of you who are interested in the heat map code, FMTD means that it expects an integer. And what had happened earlier is that total CM was coming across as a floating point. So what I did is I just prompted it, convert values in total CM to integers. And then I got this, and now my previous code works. So here is my confusion matrix. And now finally, I'm going to do the using the leave one out model. And this one, I actually did play a lot with the AI and then going through Stack Overflow. And I made sure, even though it says prompt, much of this code was not generated through AI. And actually, I have it here because it was doing it as part of the loop, and that was very inefficient. So I used my own understanding and my own knowledge. So it goes to show you that AI is good for some things, but humans still have brains more powerful. So basically, now it's going to do the leave one out. It's going to use that leave one out object, and it's going to go ahead and split it with the LOO, and then it keeps appending it. So the Y true and Y predicted. So then it can create the confusion matrix. So now what we have done is we've run if this had 500 observations, we would have run 500 different models. And the accuracy has just gone up a tad bit. Like it was 781, now it's 787. But the leave one out was computationally intense on this machine. It took maybe 10-15 seconds rather than being instantaneous. And I plotted it out. Now, to those of you who have looked at the heat map code, you probably figured it out. The color palette. So when I said red and green, what it was doing is it was still scaling it. So the red were the lower numbers and the green was the higher numbers, which worked out for me because in this column diagonal, this was the true positives and the true negatives. The higher numbers it put as green. But with this particular one, it wasn't working out. So I manually said red, green, green. So it was creating three cuts it was scaling the numbers into three different pieces. It was trying to do it in three colors. So I'm saying for the very lower ones, use red, for the medium, use green, and for the higher ones, use green. And that's how I was able to get 205 to also display as green. But in any case, if this doesn't make sense, then I wouldn't worry about it. I have used a little bit of sleight of hand in creating these confusion matrix colors, and there's probably a much better way out there. Well, if this video has helped you, then I'm happy. Thank you for listening.